Hi, my name is Muhammad Harbin Ali and my number matric is B122310656. So my group will present about the electronic system for the project assignment BERE 2353. Okay, next we go through for the group of member. We have Muhammad Hafiz bin Muhammad Rahizan, Ashraf Rafiq bin Muhammad Riza, Muhammad Khairul Rais bin Omar, and me, Muhammad Harbin Ali, Haris Iman bin Muhammad Rahfidi, and lastly, Yip Chizal. Okay, that's all. This is my group of member. So now I will talk about the introduction for the project assignment. Alright, this is my group will present about the project and assignment. So we have oscillator 1 and oscillator 2. Then we have active LPF, means active low pass filter, then rectifier, voltage regulator, and load. For the oscillator 1, wing bridge oscillator, and same like oscillator 2, but the frequency is different. Then we go through the active LPF, means low pass filter. We have second order butterworth response and the cutoff frequency is 8 kHz. And then rectifier for the full bridge rectifier, then voltage regulator, and the output voltage is 5 volt, and load rate power, the power is 1 wattmeter. Okay, that's all from me. So now I will pass to my friend to present and explain about the oscillator 1, oscillator 2 until the circuit load. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Iman bin Marafidi from BRT 2/1. Today I'm going to present about electronic system report. So my part is oscillator 1 and oscillator 2. Both oscillator using the same type of oscillator, which is wind bridge oscillator. The difference only resonant frequency, which is 1K for oscillator 1 and 20K for oscillator 2. Okay, let's see the calculation. I assume the C is 0.023 microfarad to find the R value. So we use the frequency resonance formula to find the R value. So we swap the FR and R here, can get the new equation. So we insert the value, and then we can get the R value is equal to 4.82 k ohm. So amplifier resistor ratio, the formula is RF per RA equal to 2, which is RF equal to 2RA, 2 times by 8K is 16K. Okay, let's see the circuit. This is the circuit for oscillator 1. This is the value RE, RF, R and C capacitor. So let's run this. So you can see here there is nothing on the graph, so we need to increase the okay. As you can see at 50%, there is distortion when at the wave signal, so we need to lower the percentage until it's got the smoother waveform, which is at 40%. So you can see here, you can see a smooth waveform being generated when it's at 40%. Okay, let's go to oscillator 2. Oscillator 2 given is FR equal to 20 kHz. So the calculation is the same as oscillator 1. We need to assume C and RA using the frequency response formula and insert the value, and then we can get the resistor value is 975.77 ohm, and the amplifier ratio is 2RA to 20K is equal to 40K. So for oscillator 2, the circuit using the same as the oscillator 1 because they are both the same type of oscillator. So let me run this. Okay. So you can see here, when I put it at the magnet, you can see there's a bit of distortion. So we will just lower it back. Okay, you can see here. The waveform is got a slightly distortion, but it's still the waveform is still sine wave, so we can accept that. So this is the wave signal for the oscillator 2, and this is for oscillator 1. I think that's all for me. Thank you.
So now I will talk about active low pass filter, second order. So first of all, I will introduce myself, Muhammad Hafiz bin Muhammad Raizat, and my metric number is B122310603. So the first calculation for second order in Butterworth response, as we know, RF will be divided by R1, so 0.5x6. So how we get the 0.5x6 from this table? Refer to this table for the second order, minus 40. So refer for the R1 divided R2, 0.5x6. So from the question is active filter Butterworth response, the cutoff FC frequency give 8 kilohertz. Alright. So we assume RF 2 kilo ohm. So RF will be 2 kilo ohm divide 0.5x6. So when we calculate, we will get the R1 3.413 kilo ohm. And second, for the cutoff frequency, we assume 8 kilohertz. And then for the equation, 1 divide 2 pi R multiply C, which means resistor multiply capacitor. So the capacitor we assume as a 0.5 nanofarad. So now R is 8 kilo. So the equation will be 1 divide 2 pi FC multiply C. So we just put the value in this equation and then calculate the R. We will get 39.79 Hz. So R3 equal R4, we will get 39.79 Hz. So this is table. So now we will go to the multisim. So this is a active low pass second order Butterworth for bob plot. So this is a circuit. As we know that we just calculate and then we just put the values number in this circuit. For example, this RF, we know RF is we assume 2 kilo ohm, and then R1 that we get from the calculation 3.413 kilo ohm, and then for R3 and R4 39.79 ohm, same as R3. For R4, for the capacitor we use 0.5 nanofarad for the two capacitor, and then for the AC voltage we assume for the voltage peak to Vp and the frequency is 8 kilohertz. So now we run. So this is a bob plotter graph. So now we move the cursor and then we right click, set as value. As we know, cutoff frequency is 8 kilohertz, so put the number 8 kilo, and then so that we will get the cursor for the dB 8 kilohertz. Why 8 kilohertz? Because the cursor just doing the low pass filter from this point to the right point to the right. So we know this is just start for the low pass. Alright, and then we move to the oscilloscope result. So this is oscilloscope result, same as the before this, the resistor and capacitor from the equation calculation. So we on. So this is the result for oscilloscope that I get. For peak to peak channel 1, I will get the 3.99 volt, which means 4 volt, and the max value for channel 1 is 2 volt. For the channel 2 peak to peak, I get 6.32 volt, and the max 3.16 volt. For the channel 2 frequency, we get 8 kilohertz. So that's for the result oscilloscope. So when I combine the circuit between plot and oscilloscope. This is I get. So I will show the result. So for the buck plotter, same, we just repeat what we do. So 8 kilohertz, and then for the oscilloscope, there we pause. So same, the result is peak to peak 3.63 volt, and then followed by this result. So that's all for me for the active low pass filter. So I will pass to next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairul Rais bin Omar. My matric number is B122310067. Okay, today I will to demonstrate full bridge rectifier circuit in multi-sim and how to calculate calculation in rectifier circuit. Okay, first from full bridge rectifier, we use SC power supply, diodes, capacitor as a filter, and resistor value is 47 kilo ohms. Okay, next we go to the calculation. For the calculation, for the given capacitor is 1 microfarad. In this part, we assume the Vin is 2.5 Vp, frequency 100 Hz, and the resistor value is 40k ohms. Okay, to get a VDC, we just 2 Vin over pi, and we get 1 over 592 volt. To calculate VRS, 0.707 multiply with 2.5 to get VMS 1.768 watt. For IDC, we calculate by using formula VDC over resistor, and we get 33.87 microampere. For real ripple, we use formula IEC over 2FC, and we get answer 0.169 volt. For bridge factor, we use formula square root VRMS over VDC square minus 1, and we get the answer is 0.483. For Vout, we use formula we P in minus 0.7 multiplied by 2, and we got the answer for Vout for calculation is 1.1 volt. Okay, next we go to demonstrate. Okay, by demonstration, when we demonstrate, we go to oscillator, and okay, this is the waveform sinusoidal of the full bridge rectifier, and can you see the channel 1 is input and channel 2 is output, and we can see in channel 2 the waveform have been rectified, and we can see. Okay, this all from me. Thank you.
Assalamualaikum. My name is Asharafiq bin Muhammad Liza. My message number is B122310585, and I from 1 BRT 2/2. Okay, today I will present in subject BERE 2353 electronic system. So, okay, next for this project, my part is in regulator, voltage regulator. So next we go through to the design specification. It is for voltage regulator. The requirement is voltage output must be 5 volt, and the voltage regulator type is op-amp shunt regulator circuit. Okay, next. Okay, this is my circuit that I built in multi-sim. Okay, the component that I use is DC power. I have set it to the 23 volt. And next is capacitor. Value of capacitor is 1 microfarad, and I have 4 resistor. resistor 1 is 1 kilo ohm, resistor 2 or RL is 25 kilo ohm, resistor 3 and 4, yeah, same value, 10 kilo ohm. Okay, next component is OM 3T diode. Okay, next component is transistor, BD135, and the last component is diode Zener. I have set by calculation 2.5 volt. Okay, now let I show the result for my circuit. Okay, after I press the run, I will turn on use the multimeter to see the voltage output. Okay, so here the result that I get is 5.001 volt, which is I have achieved the requirement by this question, which is 5 volt. Okay, next part I will explain a little bit about the calculation. So here is the calculation that I do for get the value of diode Zener. First, the formula that I use is P out equal to 1 plus R3 over R4 and multiplied by voltage Zener, voltage diode, and as I said earlier, R3 and R4 is same value, which is 10 kilo ohm, and voltage output 5 volt as in equation. And then okay, so next is we just put the value to the equation, which is 5 volt equal to 1 plus 10 kilo over 10 kilo and multiplied by voltage Z. And next 10 kilo we will get 1, and after that 5 volt equal to 2 VZ, voltage Z, and we have to bring the 2 to the left side, which is 5 over 2, and the final answer we get 2.5 volt. So that's why I set the diode is 2.5 volt. Okay, I think that's it from me for the voltage regulator, and for the other part my friend will continue. Okay, thank you.
Alright, so now it's my turn. I will present about the load. So the load, we have load rate power. The power is 1 watt meter. So this is my calculation. Okay, the power load given is 1 watt meter, and then the voltage load is 5 volt. So for the formula, power load wattmeter equal voltage load square divide resistor load. So we put the value given to in the formula. So 1 wattmeter equal 5 square divide resistor load, and the answer is resistor load equal 25. So this is my figure for the circuit in multi-sim. So we go to the multi-sim. Okay, so this is my part. We have a wattmeter, resistor 25. 25 I get the 25 this value because I get from the calculation, my calculation. So this is AC voltage. I using the 5 volt, lamp and ground. So this is my circuit for the load rate power. Okay, so when I simulate, we press the voltmeter, and voltmeter will given the value of this. Okay, this is my value of the load rate power. Okay, so thank you. That's all for me. Thank you.
Hello everyone, my name is Li Gao, and now I want to share about the circuit for our electronic system project. Okay, now is our circuit. For here we have oscillator 1, here oscillator 2, here summing, here is active low pass filter, and here is rectifier, here is voltage regulator, and the last one is load. Okay. Here for the oscillator 1 and 2, we will generate 2 signal, which the signal will sum up together, and the second one for the summing. The summing circuit here will combine the signal from oscillator 1 and oscillator 2. Then for here, active low pass filter, the combined signal is passed through the low pass filter, and then it will remove the high frequency signal. It will remove the high frequency noise. And then next, here is the rectifier. The filter signal is sent to the rectifier. Then it will converting to stable DC signal. For here is stable DC signal. And then the next one is voltage regulator. The voltage regulator will ensure the output voltage to remain the constant. And for the next one is load. The load section is used a transistor to drive the load with regulator voltage, and the meter measure is for the output. Okay, now let's see for the output. Run it. Okay, you can see the output. The output is 906 millivolt. Okay. This comprehensive flow ensures the circuit has two input oscillator, process them, and provide a stable output to drive a load while allowing the measurement and adjustment. Okay, that's all for me.
Thank you for watching.